Tina, like a paper towel, is that the same thing?
Mhm.
All right, so Unit 2, equations. There we have a microwave. Laura, Kelly, Tia sold boxes of cookies for a fundraiser. Kelly sold 15, less than Laura. Tia sold twice as many as Kelly. They sold a total of 83. How many did each one of them sell? Okay, so let's set up an expression for each girl. And by the way, there's usually more than one way to work a problem. The way I'm showing you, you don't have to work it this way if you can figure out another way and it's better for you. This way, I'm showing you how to set up expressions because that's one of the skills that we were supposed to teach you is how to set up an expression anyway. If I set up an expression for Kelly, it says that Kelly sold 15 less than Laura. So that means I'm going to write for her, K equals 15, well, L minus 15. Now, Tia, she sold twice as many as Kelly. So that means Tia equals 2 times L minus 15. Because it's twice as many as K. And then we got Laura, who we know nothing about. But what we do know is that Kelly plus Tia plus Laura sold a total of 83. Why am I writing it down? Because when I do this, every time somebody's going to forget Laura. They're going to take L minus 15 plus 2 times L minus 15 and say equals 83. But there were 3 people, so you substitute those 3 values. K is going to be L minus 15. T is going to be 2 times L minus 15. And then Laura is just going to be L. Did you see what I did there?
Yes, ma'am.
You don't. No, I'm going to get to my color code here. This represents Kelly, Tia, and Laura. If I simplify Tia, this becomes 2L minus 30. You still got the rest of the stuff here. So I'm going to bring down L minus 15 and the L. Go ahead and get your like terms together. It's 1, 2, 4L. So I got 4L minus 45 equals 83. I'm out of space and come up here. That was 4L minus 45 equals 83. And I need to move the 45, so I'm going to say plus 45. 8, 21, 28. Divided by 4. L equals 4 goes into 12 3 times. And then, okay, there we go. So that means Laura is 32. I'm going to come over here and write 32 for Laura. And now if I take 32 minus 15, that'll give me Kelly. $17. Now if I just say 2 times 17, I get 4. The reason I said 2 times 17 is because it said that this right here, Laura, is 17. So L minus 15, 17. And those are my 3 answers right here. I know you don't have a square on your paper, but number 2, I drew a square because I like to get visuals. If you have a square, all the sides are the same, right? The length of a square is increased by 5 on one side. The resulting perimeter is 84. Perimeter means you added all the sides up. So what I'm saying is if I add up x plus 5, x plus 5, x plus 5.
4 times x plus 5.
There you go, thank you. Shorthand way. There's 4 sides, and it's x plus 5. All of that's going to equal 84. I literally have people sometimes who would write x plus 5 on here 4 times. And I am okay if you do that, as long as you understand what you're doing. But all of them are the same thing. You're still going to get 4x plus 20. And now subtract your 20 and divide by your 4. 4x equals
16.
if you were checking your answer, you could add 5 to 16 and then multiply by 4 and get 84, so you know it's right. You get it? You can increase it and then see how many all the sides would be. If I was checking it. No, you don't have to do that. I was just checking it. Okay, 3 and 4. You better know how to do those on your own. Like for real. Those are just solving two simple equations. Yes, I know one of them has decimals, but that don't matter. You can use your calculator. Solve 3 and 4 on your own. I didn't talk through that because y'all know how to solve an equation that's that simple. However, I do want to talk you through number 5 and number 6, 7 and 8. You remember that always, sometimes, never?
Yes, ma'am.
Yes, okay, so this is kind of getting us to that point where we're going to answer that. However, the first one just says, are these equivalent?
Mhm.
So the answer is going to be yes or no. Got it? Are they equivalent?
Yes,
How do you know?
because.
Solve them out.
Yeah.
It shows you.
Okay, that works. You can solve and then see. Yeah. So if I were looking at 3x plus 9 equals 6, then I would have 3x equals -3. And when I divide, I get -1. This right here will give me the same thing when I subtract 3. So are these equivalent? That's a yes. The next one, are these equivalent?
No. Oh, wait, yeah, they are. No, wait, yeah. I said yeah,
I said no.
but it might be wrong.
Does anybody say no?
Yes.
How many of you say no? Just you? How many of you say yes? Nobody. Y'all stop being scared to answer. Like really, you do not have to be scared to answer. It is okay if you're wrong. There's a large percentage of the day when I am, so it's okay if you're wrong. Like, just think about it. Are they equivalent?
I said yes, but
And I'm glad you stuck with your answer. But how do you know that? Are you just
because
guessing?
I did cross multiply and I did x equals 4 for x minus 0, the same thing.
Thank you. Even though you might not realize this, you could cross multiply because imagine the 4 is over a 1, right? So that means I could cross multiply here and get x. And if I cross multiply here, I will get that it equals 4 times x minus 2. I don't even have to finish it because this says the same thing. If they say the same thing, they're equivalent to each other. But now there's scenarios of always, sometimes, or never. Always means you're going to get an answer where it's going to be like all real answers or infinite solutions because the numbers are going to be the exact same. The values are going to be the exact same. Sometimes means you'll be able to get an answer in a time. You'll be able to get an answer for x at least one time. Never equal means it will never work. I don't care what you get for the value of x. You will never have a solution that works. So sometimes is, yeah, I can solve it and I can get an answer. Always is, okay, this is going to be like all real numbers type stuff. Never means no solution. So, what about number 7?
I said never
Why do you say never?
because I distributed and I got -6 equals -3.
Good job. If you distribute 2x minus 6 equals 2x minus 3, you know from this step you would cancel out your x's. Or you could just look at it and say they're not the same thing. You literally don't have to stop and mark up the 2 x's. If you see that the only thing different is this and this, they're not equivalent. But if you were marking them out, this is a problem which would be no solution, because you see you got -6. Does -6 equal -3? No. That's a no solution, never problem. Never, never, never will you get an answer. Now, what about number 8? Always, sometimes, or never.
I said never.
I say
Wait, no, sometimes. No. Never.
I love how you're helping and you're working with me. It's like you're the only person talking. You did say something as well, but you're like the only person, meaning ain't nobody who hears it. Okay, it's never.
Yeah, because it's X equals Y. Or could it be sometimes because it could,
Yeah, because you can put, well, X and Y could equal the same thing.
yeah.
There you go. Yes, this one is sometimes. And it will only work. And I'm going to put this what she said. Because if X equals Y, then it works. Because if your X is 1 and your Y is 1, you see how this will work?
Mhm.
You will get an equal answer. But that only works if the X equals the Y. You hear me? If you can come up with one scenario where it will work, then it's a sometimes. All right, so number 9 and number 10, well, actually number 9 specifically, this is like a proportion problem, where you can cross multiply again. So you cross multiply this way, and then this way, you can solve for X, okay? And this is gonna give you a fraction, kind of repeating decimal answer. So if you haven't already done it, go ahead and do that right now. Isn't this a repeating decimal? If anybody got to the point where you divided the 5 by 9, tell me, you want to get that far?
I just got, wait, what? I just got 5/9, that's it.
Oh, okay. Because sometimes I have some students who will see this and divide and try to change it to a decimal. But I think it's a repeating decimal. So if it ever gives you a repeating decimal, please leave it as a fraction. Okay. Number 10 and number 11. These problems are what we call literal equations. Literal equations are problems where you are just rearranging the variables. Your final answer ain't gonna be nice and pretty. It's not gonna be a whole number. It's not gonna be integer. It's not gonna be just one set value. It's going to be an expression that has numbers and or variables left, okay? So if you just rearrange them to solve for a certain value, you're gonna end up with an expression. And that doesn't mean you did it wrong, that means you actually did it correctly. If we're solving for Z, I want to get this letter by itself. Immediately, my mind thinks, get rid of the fraction, get rid of the fraction.
So you multiply by 4.
There you go. Getting rid of the fraction means I'm multiplying by 4. Because pretend that there was a 1 here. I could cross multiply and get 4x equals 2y minus z. You have now made it look so much easier. If we want the z by itself, what do we need to move away from it? Subtract the 2y. Thank you. Now I'm hearing people on the other side of the room. 4x and 2y, are they like terms? No, don't you dare put them together. You have to write 4x minus 2y. And look, this is not z. It's negative z. There you go. Divide by -1. Be careful. So many people are careless and they look at this and they're like, oh, I'm done. Because they moved the 2y. But this sign right here stays with this. So that means it's an understood -1. Everything is divided by -1. You get a -1, you get a -1, you get a -1. Changes all the signs. So this gives me my final answer. Z equals -4x plus 2y. If you write it the other way around, I'm okay with that because it's the exact same thing. Typically, when you write answers in math, you go in order of the variables, so x comes before Y in the alphabet. So most likely, answers will be presented that way, the one on top. But the bottom means the same thing, so if you give me that, I'm gonna let you have it. All right, see what I mean when I say literal equation?
Yes, ma'am.
Look at the next literal equation. What do we solve for here?
So do you divide by 2?
There you go. I was gonna say there's two ways we could do this. You could distribute or you could divide by 2. So you said either one of them, you were right. She's dividing by 2 because she sees that this entire thing is being multiplied by 2. So if you divide by 2, it gets rid of the 2. And then you end up with A over 2 equals just L plus W.
You subtract the L.
There you go. Looks pretty simple now, right?
Yes, ma'am.
Doesn't it? I mean, do y'all see how we did that there?
Mhm.
You sure? Y'all are super quiet. Okay, let's see. So I've got A over 2, and I'm subtracting the L. So my W equals A over 2 minus L. If you like this method, stick with it. If this method was like, I don't know how you got that, then let me just say, you could very well have distributed. If I distributed, let's show you another way. Don't worry, I'm gonna write this fast. It would have been A equals, and then distribute 2L plus 2W. Then you have to subtract the 2L, which would give me A minus 2L. But that's gonna equal 2W, and look what happens last. You end up getting the exact same thing, because if you get A over 2 minus 2L over 2, that's the same thing as this answer right here, because that answer is simplified. I actually like the first method better because it's faster in my opinion. The last two problems are inequalities. For inequalities, there's a major rule you have to remember. Anybody think you remember?
You said what?
I was about to say there's a major rule you gotta remember with any inequality, and somebody said it. You have to flip the sign when. When to this. There you go. Flip sign. When we say sign, I want to say the inequality symbol it is. Like these symbols right here. Whatever these are right here, you flip those symbols when you multiply or divide by negative. Let me show you what I mean. Number 12. If you're solving this, you can move the 3x over, or you can move the 13 over. It doesn't matter. Or you can move the 5 over. All you need to do is just get the x on one side and the number on the other side. So if I'm moving the 5, because I like for my variable to be on the left side, I'm just going to do it. I just love my variable on the left side. So that's why I'm going to subtract the 5. When I subtract 5x, it is a like term with negative 3x. So I'm going to have negative 8x plus 5 is greater than 13. At this point, I'm subtracting 5. When I subtract 5, I got negative 8x is greater than 8. One last step and a flip must happen.
And you flip the sign.
Sign is flipped simply because I divided by a negative number, okay? So my answer is now going to be x is less than negative 1.
Is it okay if like I flipped it? Like I did negative 1 and then is this greater than?
Do not write negative 1 is greater than x.
I didn't write that. I flipped the sign. Like I did it the other way. I don't know what. Wait, I didn't subtract by 13.
I prefer you write it like this instead.
Okay.
Woo! Look at number 13. Any clue out? However, how do you start?
Cross multiply. I put a 1 under the 5.
Love the fact that you on top of that. Rest y'all. Are we going too fast? You sure?
Mm-hmm.
Okay. So put a 1 under the 5, and let's cross multiply. I'm gonna have negative 3x plus 2. Because if I multiply by 1, it doesn't change. And then I bring the sign right here. And then 4 times 5 is the 20. So you understand this right here gives me 20. This right here is just negative 3x plus 2. Finish this one on your own.